In today's video, we will talk about drawing a complex molecule, but not drawing by ourselves, but we will try to get the structure from some published manuscript. So last time we had seen how to get a structure from a zip file. That is one option. Another option is to get the Cartesian coordinates from the published manuscript and use those coordinates to get the structure. It is always beneficial to get structure from already some published manuscript because it saves a lot of your time. And besides that, the structure that you get from the published manuscript are generally good one. So let's say we came across recently an interesting article that is water-soluble chiral cyclic peptides and their sodium and gadolinium complexes, a study of conformational and relaxometric properties. This is a combined experimental and theoretical study. And we are more interested in their cyclic peptides. And if you see here, they have chiral center, they have cyclic structure, and because of chirality here, it is not very easy to draw, especially by someone who is new to computational chemistry. Now, if you open up this manuscript, that's in PDF, I have downloaded it, you can see there are many structures reported in this manuscript. All of them are the cyclic peptides and their metal complexes. We are interested in the structure mentioned in this figure 7. Let's say we are interested in 2Na with 2 negative charge or 2A sodium complex with 2 negative charge. And if you read here in the figure 7, it says, see the supporting information for the Cartesian coordinates. It is good that they have mentioned that this theoretical calculation, like structure here, or theoretically calculated structure, is also given in the supporting information in terms of Cartesian coordinates. In case you're not able to see this type of information in the figure caption, what you can do, you can scroll it down to the end of the manuscript where it says data availability statement, and there you can see for supporting information, it says down here that Cartesian coordinates of these compounds are given in PDF. You can see here these animations are fair data are given in the zip files, whereas this like these Cartesian coordinates are given in the PDF file. And I went to the paper again. I went into the section of supporting information. There I clicked on this PDF file and I have downloaded this PDF file, this one here. So I have manuscript and the PDF file with the supporting information. If I open the supporting information file, you can see in the index at the end it says computational details, and below computational details it says Cartesian coordinates and energies of calculated structure. So it says it is on page S58. If you go on page S58, this is S58, and there you can see it gives the structure of 2Na with 2 negative charge, and below this label here you can find all the coordinates. In Cartesian coordinates, it has atom symbol, it's X, Y, and Z values. And you can see these are the values for all of the elements present in this molecule. So we have to copy these coordinates. But before doing this, what we can do, we can go back to Gauss view, and let's say first we save a random file. Let's say if I click this CH4 structure here, and I save as like methane, and I am going to save it in downloads. Let's say I save it. Now to copy the coordinates from the internet or from published manuscript into Gaussian input file, what we need to do, we need to open up the file in Notepad. If I go to the downloads, I have this methane.ggf. I open it in Notepad, and you can see here I already have the coordinates for methane. These are the coordinates for methane, and here it shows the connectivity. Let's say I delete the coordinates of methane and connectivity. I also delete this word geom is equal to connectivity. And now I copy the coordinates from this sporting information into this file here by Control C and Control V. Oh, sorry. Let me copy this one here. I copy it and then I paste it here. Here you go. I have copied the coordinates from the sporting information file into this input file. I need to make sure a couple of things because the Cartesian coordinates are not present on a single page. They are expanding to 2 pages, and when you're copying coordinates from 2 pages, generally the page number also copied there. So if the page number is copied, you have to make sure that the page number that you have copied should be deleted. And here you can see, this is the page number, which is copied from the PDF file. I need to delete it. I need to also delete the blank line. And if you remember, this complex has 2 minus charge. So I need to change this charge to -2. So now it says the charge is -2 and multiplicity is 1. And other than that, it's now perfectly fine. If I save it and then I close it, then I open up this methane.ggf, although I did not change the name yet. If I open up this methane.ggf and drag it into Gauss view, and here you can go, I have the structure copied from the Cartesian coordinates of the published manuscript into my Gauss view. And now I can use this structure, and I don't need to worry about because this structure is already optimized by those authors. So all the structures or geometric parameters are perfectly optimized. I can use this structure for any properties, provided that I'm using the same level of theory as they have used. If I'm going to change the level of theory, I have to re-optimize it at my desired level of theory. With this one, I believe you have learned how to get the structure of a complex molecule from the published manuscript.